All right, it's 9 o'clock on my clock. Good morning, everybody. Good morning to the guys who are joining in from US, and good evening for the guys who are joining from India. It's my immense pleasure to host this boot camp, and I would like to introduce myself. My name is Sunny. I am special advisor to BlackRock, and then I do have our guest speaker Krishna Reddy as well as the Lee Hammer, who is the founder of BlackRock. Um, let's give it a couple minutes before we jump into and start the boot camp. I see a few people joining in. Let's give them a few more minutes. Right on the 9:05, we will begin. Good morning to the guys joining in from US, and good evening to the guys from India. It's my immense pleasure and honor to introduce myself, Sunny. I'm special advisor to BlackRock recruiting. It's my honor to start this bootcamp and get going. So just a little housekeeping things before we go in. So the schedule for the bootcamp is today is the day one, August 6th. It starts from 9 a.m. to 10:30 a.m. Pacific Standard Time. And in Indian IST, it's 9:30 p.m. to 11 p.m. IST. And then you guys can see the schedule. Just one quick reminder is if you would like to complete the entire bootcamp, you have to register for all six classes. There is no other way in order to get this going. So the day one agenda, we have a message from the founder, and then we have a presenter introduction, and then we have the module one, which is introduction to the DevOps, as well as the module to Git and GitHub. We'll go over this, and I just want to give a spoiler alert. Today would be mostly onto the theory side of it. Day two would begin with practical things, getting into the weeds of the DevOps bootcamp into the Azure and other technologies. So it's my pleasure to introduce Lee Hammer, the principal and the founder of BlackRock. Lee, take it from here.
Sure, thanks, Sunny. Truly grateful to be here today. Grateful for both Sunny and Krishna and what they've put together. To tell a bit about myself, I spent nearly a decade in IT consulting, managed relationships with Walmart Labs, American Express, Levi Strauss, and some others. And the reason we started BlackRock was to be of service to people. I'll tell a bit more of our story as we move to the next slide. So what we found from working with CTOs to hiring managers, from nimble 100-person startups to Fortune 100 companies, is they were in desperate need of connecting with good engineers. They felt that, hey, we're starting to see just repeat candidates from different consultancies. And so we were eager to be able to connect with developers who were maybe not actively looking on the market. And then on the other side of that, what really troubled us is we were disappointed to see that engineers and DevOps professionals were receiving job descriptions in their inbox continuously with no sort of personal connection. And from where we come from, the goal and our mission and our purpose is to be of service to you. And I'd like to congratulate all of you for being here in attendance today and investing in yourself. You made a wise choice, and we hope that we can be a resource to you, not just through this training, but potentially as career advisors as you navigate your course through the professional world. There's a few things we do. We initially started out in software recruiting and placing people, and we've been fortunate enough to grow into software training, consulting, and even doing some software development projects for clients as well. As the needs of our clients changed and shifted over time, we're able to find new avenues to be of service to them. What I'd like to do now is a small promotion for those of you in the Phoenix area. We're lucky enough and fortunate enough to be the organizers and sponsors of the Phoenix React JS meetup. Prior to the COVID pandemic, we were the largest tech meetup within the Phoenix Valley, regularly having 200 attendees on site. We have over 2,500 members. And what it is it's a community that's focused on serving one another. We aim to bring the best of the best in within front end and JavaScript and React technologies to bring their best practices into the Valley and share and teach with others. We've had Michael Jackson and Ryan Florence and some of the top names and some of the top influencers on Twitter come to visit us and share their learnings. We host it every third Thursday of the month at Carvana, and we'd love to have you there. Outside of Phoenix React JS, if we'll move to the next slide, we began to grow other trainings as well. We've had such success with the React JS meetup, and we've seen the impact that it's had on people. We've had people who were entry-level engineers or fresh out of a boot camp, and they get plugged into the community, which accelerates their learning. And we look to serve them by connecting them with different people we know, whether it's a placement for us or just introducing them to a friend that helps them to level up their career. And from kind of seeing the impact that that had, we were really pushed or motivated to push into different areas. And now we're offering Azure and MuleSoft, C++, Terraform, as you can see on this slide. We want to expand our reach and expand our impact and to be of service to others, to help you level up your career. I see a hand up from Nilima.
Unfortunately,
Unmute
Nilima,
her.
if you have a question,
Maybe in the chat.
could you just, sorry, Lee?
Maybe they could drop it in the chat if they have a question.
Yes, that's right. Yeah.
Okay.
Yeah, go ahead, Lee.
Okay.
We'll take the Q&A at the end.
Yeah, that about wraps it up for these offerings. Again, me and Sunny both align with this mindset of it's all about people. Helping you to learn and grow and connect you with opportunities that bring you joy in the workplace. Anyone can find a job, but our goal is to connect you to a place where you feel fulfilled and motivated and that you can grow. We just want to be a part of that journey. I think that's it for that slide, Sunny. Okay.
Thanks, Lee, for all.
Yeah, thank you, Sunny, and thank you, Krishna. With that being said, I'll hand it back over. Thank you.
Thanks, Lee, for all that message and the introduction about BlackRock. At this time, I would like to pass on to Krishna to begin the training and like introduce himself. Krishna, if you could share the screen from your side and then kick this off from the slide, that would be great. Let me know if you have any difficulties doing that. And just another housekeeping thing. If you guys have any questions or anything, just please put it into the chat. And also with time permits, we would open a Q&A at the end of the session.
So I hope you guys are able to see my screen. Yes, Sunny?
Yes, we are. Yes, we are. You can just go into the slide mode.
Yeah. Yes. So myself Krishna. So I'm born and brought up in Hyderabad. So I have 20 plus years experience in IT industries. I've worked on various technologies. Like I was starting from Windows Active Directory, VMware, Nutanix. I worked on Azure, AWS, and Terraform. So I worked on various technologies. Right now I'm working on Azure DevOps. So this is my experience. So I've trained so many people. I've been training from last 4 years on cloud technologies. Right. So today we are going to discuss about the DevOps modules, everything. Okay. So let us start with the what is DevOps and why DevOps required in an organization. Why this has been implementing in our organization, right? So later on, I'll be talking about each and everything. So let us discuss about what is DevOps, right? So I can see this is a practice of operations and development engineering participating together in entire service life cycle from design through the development process to production support. Okay. So what exactly I was talking about, this is a practice of operations and development engineers. So these guys are both practicing together for the entire life cycle. So what does exactly mean? So let me talk about that briefly. So we are talking about, yes, DevOps is a practice of operations of development and engineers, right? So in the DevOps, what exactly happens? All three teams, I can say QA, operations, development engineers work together. This practice needs to be implemented in organization. So why would we require this practice needs to be practiced in our organizations? Because so once these three people are working together, right? You can say DevOps. So this is actually a collaboration between QA team, development team, and operations team. So once three teams will be working together, right? You'll be having an excellent automation solution. You'll be getting an excellent automation solution. So what is exactly automation solution? In what it is, which process it is going to automate? We need to know that first. The process is SDLC. So total SDLC lifecycle will be automated by using this DevOps culture. Once you deploy all this DevOps culture into our organization, you'll be having a process. Everything will be automated via SDLC. Okay. So this SDLC will be automated. So let us discuss first what are the methods, waterfall methods, and in traditionally you have different methods like you can see this is waterfall method. Earlier we were used to use this. Okay. In this waterfall method, you can see this is a top to bottom approach, right? Top to bottom approach. So what I'm trying to say is top to bottom approach in the sense. So in the waterfall method, you have a top to bottom approach. Approach will be top to bottom. In the first, you will be taking a requirements from the client. So finishing stage, it will delivery. So first you will taking a requirement from the client and gathering all the information, which technology I need to develop my code, everything will be taking the requirements from the client. So end will be the delivery. So during this process, right, this will be a lengthy process. This will be a lengthy process. Depends upon the project. It may take 1 year or it may be take 2 years. We will be not knowing. Yeah. So total this period we will be not interacting with the customer at all. This is the main disadvantage in the waterfall method. Okay. So by length, you can see that there is a lot of length duration. So here you have a challenges. So in this waterfall method, you have a challenges. First, there might be a technology change during this period, right? If you are taking 1 year, 2 years, right, there might be a technology change. Another might be whole business model might change. We never know. Client business model may change. So that is where waterfall method is not successful. So that is where waterfall method is not successful and everyone moved to now agile methodology. Everyone moved to agile methodology. So let us talk about agile methodology. Agile. So agile works on three characteristics. One is it works on modularized Second, parallel development. First, modularization. Second, parallel development. Third, iteration. So Agile works on three characters: one modularization, second parallel development, and third is iteration. So these are methodologies, right? So again, technically speaking, so it works on Scrum. Agile works on Scrum, right? So what is exactly Scrums? Scrum uses iteration and as a sprint. Scrum uses iteration as a sprint. So in the sprint, usually sprint will be having a 2 to 4 weeks. So in the sprint 2 to 4 weeks, all the SLDC, total SLDC should be completed within the 2 to 4 weeks, right? So all the sprint will be a 2 to 4 weeks. On the whole SLDC we should complete within the 2 to 4 weeks. For example, in this scenario, if I'm taking I will be taking one example. Let me take an example. So client has given me one requirement. So I've taken as divided into parts. So first module, second module, third module, and fourth module. So first module should be completed within 2 to 4 weeks. I mean, first sprint, sprint 1, and this is sprint 1, sprint 2, and this is sprint 3, and this is sprint 4. Okay. So all the modules should complete within 2 to 4 weeks. So one sprint complete in the sense what I'm trying to say, total SDLC process should complete. I mean, code building, unit testing, packaging, and C integration. Everything should be completed within 2 to 4 weeks. Now, what happened? For example, if you see that first module completed in 2 weeks, second module completed in 3 weeks, third module completed in 3 weeks, fourth module completed in 4 weeks. That means in Agile methodology, all 4 modules are completed within the 4 weeks period, right? So what is the advantage of 4 weeks? So main thing is, so last stage of SDLC is, I can say last stage of the SDLC is UAT. So last stage of the SDLC is UAT. UAT in the sense user acceptance test. So where my client will be testing these modules, and once they test, they'll be giving you feedback, right? Once they test, they'll be giving you feedback. If something goes wrong with that code or anything, they'll be give the feedback, and based on that we'll be incorporated into our module. Again the sprint will run, and again we'll be developing within the 4 weeks. So what is the advantages of this agile methodology by using parallel development? So we are interacting with the client frequently. The main thing is we are interacting with the client frequently, so that you will be getting the feedback immediately, and we will be able to resolve our issues within the period of time. Whereas waterfall method, as I said, it is a top to bottom approach. First we'll meet the client and take all the requirements, and at the end we are delivering it, right? This whole period, it is taking a lot of time. It might be 1 year, 2 years or something like that. But in the agile methodology, we are breaking our application into modules. So make sure we are developing all parallelly. And we are completing each module whole SDLC process. So what is that I'm trying to say? SDLC process is nothing but total software development lifecycle. I'm going to discuss about SDLC as well. But what does it mean? Total SDLC process we are able to complete within the period of the 4 weeks. These are our all 4 modules are able to complete within the 4 weeks. I mean within the 1 month, based on by UAT it goes to UAT, and we are trying to we are contacting the client. So as per the client requirement, we are incorporating all the bugs and fixes. Again, sprint will run with it will complete within the 4 weeks again. So this is how our agile methodology is going to work, right? Now, so what exactly the agile, what it does? Okay, so first is code building, right? I can say code build. What will happen? Code build. After that, unit testing. After that, packaging. Packaging is nothing but it artifacts. We can call it as artifacts. These three will be done, right? This three or we can call as agile. So these three we can call as agile, like code building, unit testing, and packaging. So these three we can call an agile. So later on again, you will be having integration testing, right? Integration testing and delivery. So integration and testing and delivery. So and integration testing and delivery we call as a CI. I mean continuous integration. So from CI is nothing but it automate all the process like code building, unit testing, packaging, and integrating testing again, and delivery. This all for all five will be is you have you can see the continuous integration. It is an automated process. I can say it is an automated process. This CI is not new actually. This CI is not new. It has been implementing from long time. Right, this CA is not new. Now, after delivery, right? So we have a code. Now we need to release it. I mean, we need to deploy into the production servers or something like that, right? So now this code be given handed over to my operations team, like release team and deploy. This will be taken care by ops team. So earlier ops team used to do manually. Earlier ops team used to do manually, right? So only CA is automated. Only CA is automated, not CD. Earlier ops team used to have the code and they used to take that code and deploy into the production servers or UAT servers manually. So by using this, what happened actually? So as I said earlier, all the 4 modules should complete SDLC, right? This is my SDLC process: code, unit testing, packaging, integrating, delivery. Total all 4 called as a SDLC, software development life cycle. So including releasing and deployment. Okay. So I told you that last stage would be UAT, right? UAT. Last stage would be UAT. So here we had a challenge. Earlier I have took 4 modules, right? I have took 4 modules. In earlier example, I have took 4 modules. So let us take again 4 modules. Now I was able to deploy first module without any issues. So I was able to deploy first module and testing has been done without any issue. Testing has been done. Testing has said that yes, the code doesn't have any issues. Fine. Okay. A second module we have deployed into the servers. Yes, that is also fine. When it comes to third modules, I have deployed it. Operations team deployed manually, and there we have found some issues on the. Assume there is an issue with that module. Okay, assume there is an issue with that module. So testing team has found out that there is some issue with the module, and they have raised a ticket with the development team, and development team is working, and they found that there is some bugs in that code, and they try to fix that bugs. Okay, they have, by seeing that backend schema, they have changed to resolve this issue. They have changed the backup schema, or they have changed some Java version. If that module is developed on Java, they have changed the Java version. And same thing as informed to upstream, saying that yes, schema has to be changed and Java version has to be changed. Now upstream, what they have done, they have changed the version of the Java in that servers. Now, once they have changed the version of the Java version on the servers. So earlier they have deployed 2 modules, right? Again, those has to go to testing again. Again, those also should go to testing, right? Once the testing has completed, this third module will be deployed. So what I'm trying to say is, so until this testing is done, third module will not going to deploy. So at some point of time, what happened? So you can see at the time at the doorstep of the deployment, right? So there are the huge modules are gearing up, waiting to be deployed. So this was the reason. Now they have think that why not deployment should be automated. Why not delivery should be automated? So earlier CI is automated, but not the delivery, right? This is where they have implemented the tools, and delivery also automated now. There will be continuous deployment. Earlier we called as a continuous delivery. Now after the automation, you will be calling as a continuous deployment. So that is the difference between continuous deployment and continuous delivery. Okay. Manually deploying all the codes is called continuous delivery. And after that, they have found that yes, this has to be automated, and they have used as a automated so many automated tools, and they made as a continuous deployment. This is how CI/CD has started. This is called as CI/CD. So CI is nothing but whole continuous integration within the code, and CD is nothing but the after the release we will be going to deploy. Whole workflow will be using as pipelines. This whole workflow will be using in the pipelines. So this is my theory part. So let us come to technically. Okay, technically let us see. Yes. Now technically everyone will be knowing that yes, we have CI/CD in the sense CI, CD. This is operations. This is continuous integration, right? But for example, you have a requirement to VM to be installed, two VMs, one load balancer, right? Two VMs, Linux, web server, 2 VMs, app server, 2 VMs, DB server, then application is going to be installed. This is how we are going to, we have a requirement. First, the thing is we need to install the operating system and we need to provide the hardware. All right. Hardware. So now if you see there is a continuous integration and operations. We don't have hardware layer, right? So there is a hidden layer in the CI/CD architecture. We called as a infra layer. I can say there is an infra layer that is hidden. So without infra, we will be not able to do continuous integration and operations, right? To deploy the application, we should have an infra, right? So to deploy any application, you should have infra. Without the infra, how you will be able to do this? Yes, no, all right. So there is a hidden layer. We can say that is an infra layer. There is an infra layer. So this infra layer also automated. This infra layer also you can automate it by using IAC. So everything is automated. The infra layer also using automated. So how we are automating? Can say by using Terraform, you are able to automate. This is a provisional tools. I can say the provisioning tools by using provisioning tools. Provisioning tools. One of the tool is Terraform, IAC code. So by using Terraform, you can automate whole infrastructure. At the same time, you can maintain config management as well. So once you deploy your servers, right, the for patching purpose, everything, what you will be using? You'll be using config management tools. Like what are the config management tools you'll be using? Like Ansible, Chef, Salt, Puppet. So these are the automated tools you'll to manage our infra. These are all automation tools, right? Coming to CI, continuous integration, we were seeing, right, build, packaging, everything. Let us discuss about what are the tools we can use it in CI integration. First is SCM. SCM in the sense source code management, right? So what are the tools you can use it? Source code management. You can say Git. Git is a source code management tool. I can say Bitbucket. Bitbucket or something, etc. And for build automation, you can use MS Build, Maven. Packaging, and you can say code quality, SonarQube. So these are all automation tools where we'll be using in CI. So these all are workflows, right? So these workflows will be deployed into my pipelines. I can say these workflows I'll be deployed into my CI/CD pipelines. CI/CD pipelines. So CI/CD pipelines, which is a major tools? I can say Jenkins, Bamboo, or Azure DevOps. So by using these tools, you are able to use infra is automated, CI is automated, and coming to operations, what kind of thing you can do? You can monitoring, log analytics, Monitoring can be used some app dynamics. Log analytics can be integrated like API tools like to Grafana, and you can use Chef and Ansible for configuration changes, everything. So you can see everything is automated from end to end, everything is automated. Coming from infra layer, CI layer, operations layer, everything is automated. So for automation, what are the tools you are using? I have written here. Like Terraform, you'll be using Ansible, Chef, where code quality, SonarCube, MS Build, Maven, Git, Bucket, packaging. Also, you'll be seeing automation tools at the same time. For the monitoring purpose, using App Dynamics, right? Configuration, log analytics. You'll be using API integration with Grafana, and but for packaging everything, and you'll be using Ansible and Chef. These are the whole CI/CD pipeline will be an automated. You can say now total my E2E is automated end-to-end life cycle. This is my SDLC, software development life cycle. So everything will be automated. So in the real-time DevOps, right, you should be knowing all these tools. If you want to become a really good DevOps engineer, right? So all these tools you should be knowing. This is called a CI/CD pipeline. CI/CD pipeline. Right. So let me go to so this is waterfall model, and this is a DevOps agile model, and this is Kanban model. Kanban model is nothing but it continuously process will be going on. So there will be no stop at all. So it is like a pull model. So once the work is done, so other person immediately the person will push to the other people, and that person is going to work. This is a continuous process. This is my CI/CD. So we have already discussed. Let us discuss about now Git and GitHub. So if you have any questions, right, we'll be having a Q&A sessions, so you can ask questions there, right? So now let us discuss about Git and Git and so what is Git exactly? Git, I can say that is software installation, software in a local system. So it works. It is a kind of a software which should be installed in the local system. We can create a local repository, everything by using the Git. Whereas the GitHub is a distributed version control system. GitHub is a distributed version control system. So let us, before going to that, right, let me show you how to install a Git in our local system. So let me directly go to my thing. Download for Windows. So we'll be practicing Git commands, everything by using this software, Git software. So Git download. And if you are using your laptop on Windows, choose Windows, and if you are using Mac laptop, you can use Mac, or Linux. So right now I have my Windows laptop, so that I'm selecting Windows. So 64-bit. Yes. So I've already installed this software in my laptop. So you just click next, 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 finish. That's it. So there your Git operator Git will be installed in your laptop. Okay. Once it is installed, you'll be able to see it. So git bash, git GUI, and you'll be able to see this software. Okay, we'll be using mostly git bash command. Okay. Now let me show you. Git is a version control system used for tracking changes in computer files, right? So it will be working on the local system. Git is used to track changes in the source code, and the distributor version control tool is used for the source code management. It allows multiple developers to work together. So let us talk about Git more practically. Yeah. So before going to GitHub, right? So let us discuss about first what is centralized as distributed centralized version control and distributed version control. Let us first see about what is the difference between distributed and centralized. So for example, coming to centralized version control system, you have a repository here. You have a repository here. This is centralized repository, I can say, right? And developer one is working. Developer two is working, right? So in the centralized version of control system, whatever the operations you are doing here, right? Everything will be need to work on my centralized repository. What are operations in the sense? It might be pull, push, commit. These are all called operations. Okay. If all operations will be directly committed to my centralized repository, right? Committed to my centralized repository. The main disadvantage of centralized repository is the sense it should have a connectivity between this server to my local system at any point of time. Without the connectivity, you will be not able to commit my code to my centralized repository. And you can see all codes will be under centralized repository, and this is a one point failure. I can say this is a single point failure. Single point failure. Single point failure in the sense if something goes wrong with my central repository, right? Something goes wrong with my centralized repository, no one will be able to work again until unless this comes up. So here developer will not be having any code to work on that, right? So everything code will be committed onto my centralized repository, and until unless this comes up, this has to be sit idle, and no one will be able to work until this is come back. This is how my centralized repository will be working. It is a single point failure, and all the operations which I am going to work, it is directly committed to my central repository. So this is, I can say, central repository, central version control system. So coming to distributed version control system, the same. This is my repository, distributed version, I can say, okay. And developer one is working, developer two is working, developer one, developer 2 is working. So only few operations will be committed to my central repository. I can say only few operations will commit to my central repository. Like, so locally what it is going to work locally, I can say directly add command, okay, commit, clone, pull, push. So these commands, some of the commands will be working on locally. So for example, Dave in our organization, Dave 2 has come up and he is working on some code. Okay. Dave 1 and Dave 2 came in the morning at 9 a.m. and they both have their requirements and both guys are working on one code. Okay. So he has got one requirement and he has got some requirement. Now he has completed his task and he pushed his code to my GitHub. Like I can say my GitHub. He completed his task and he pushed his code to GitHub. So as soon as, let me tell you, as soon as he comes to organization in the morning, first he has to clone this whole code to in his local repository first. And the code will be under his laptop local repository and he'll be modifying the code and later on he'll be pushing the code to my central repository like GitHub. Okay. Now at 4 o'clock, he finished his work and he pushed his code to central repository. Now, Dave 2 also is completed his work. While pushing the code to central repository, right? You will get an error saying that someone has already pushed some code and it has that main code is having some changes. First, you fetch that code into your locally and again push that code to central. So this is the error you will be getting. Now, Dave 2, what he will be doing? He will fetch the code from the central repository to his local system. Again, he will merge it and again he will push that code. So in this case, what it is happening, what I'm trying to say is, so each laptop will have a local copy of entire code. Try to understand. Each laptop will be having a local copy of the entire code. It is not a single point failure. It is not a single point failure. Not single point failure. So if something goes wrong with this, right? Even though if something goes wrong with that, yes, these people still able to work on the local repository and he can add it, he can modify their files, he can add, he can commit, and everything can be done until unless this up. Yes, later on they can push the code to my repository. This is the distributed version control. So Git is a distributed version. This is how the distributed version control is going to act. Whereas centralized version control, you will have only a single point of failure where all the operations will be running on my central repository. That is a single point of failure. If something goes wrong with my central repository, yes, whole total code will be done, or nobody will be able to access that code until unless it come back. Right? They are backup. The team will be there and they will be backing the code, and until the server is up, no one will be able to access that code. Whereas in distributed version control system, yes, if the server is down as well, no issues. You people will be having a local copy of that code and they'll be working on that code. This is the difference between my distributed version control and centralized version control. Okay. Let us talk about so I was saying that yes, central repository will be having and everything will be done under my central repository. this Git is installed and maintained on your local system rather than cloud. So what I was saying, Git is just a software. We'll be installing on our local laptop and we'll be working on the Git and local repository only. I can say that is a local repository. And it is first developed in 2005. And whereas Git is a designed for the Git repository hosting service. It is I can say it is a cloud service, right? How to install Git, and we have already seen. Now let us see the practical place. I'll be showing you two types of Git. Uh, Let me first show my GitHub account. One second, I'm using code. So you can see this is my GitHub account. So to work on the GitHub, you should have an account, or else you can just try to create any account. GitHub.com. So let me use. Okay, let me show you my GitHub. So this is my GitHub account, right? We have all repositories under my Git. Okay. So first, if you see that there is an existing repository, for example, I'll be creating a repository. So new. So this is my account and I'm creating a repository name. So let me create any repository like bootcamp. This is my repository name. You can see public and private. You can see public and private. Earlier in I think around 1 to 2 years back, this private was they were used to charge this for private. Now the Microsoft has overtaken this. Now this also become a free now. Right? I'll be using a public, where if you use public, right, everyone will be able to access our code from Git. If you use private, whoever will be giving an access, they only able to access our code. This is the difference between public and private. So let me choose public and create repository. So now I have created one repository. Right now let me start using. Now this is my repository, which is empty repository, and this is my folder, right? So let me first clone my repository to my local laptop. We can do either ways. We can just try to initiate the Git and you can even push our code to the repository, or you can clone the repository, existing repository to our local system. You can do either way. I'll be showing two ways. Now this is my repository. To clone the repository, let me use this is the URL. I am copying this. As we have already installed Git, right? So when you right click, Maybe I'll be showing more options. So let me see. So this is git bash. So click on git bash. Now you will be having a git bash console here. Git bash console. So now my requirement is that, so I have a repository which is already an existing repository that needs to be cloned into my local repository first. So what is the first command? Git clone space and the repository URL. Enter. So once you hit it, this bootcamp folder has been downloaded to my local repository. So now this is a Git repository. I can say this is a Git repository. So let me create some files here. I have created 3 files under my local repository bootcamp, right? So now, so my requirement is yes, as I said earlier, one developer came in the morning and he cloned the existing repository to the local system, same as it is. Now he has developed his code. So same way as it is now, before going the home, he need to push this code to my central repository, right? First is a git clone command, and we have cloned that repository to my local. Now I have modified this code, everything. Now I need to push this code to my central repository. I'm in GitHub. So what would be the command? So let me first go to my, let me change the directory. I'm into now bootcamp. So first command would be git status. Let us check what is the repository status. So if I say git status, it is saying that on branch main, you can see I'm into main branch. So you can see here main branch. So I'm not into any new branch. I'm into directly into the master branch. I can say I'm into master branch here. Now it is saying that untracked files. So there is some files which is already created. That is those are untracked. Now we need to add to the staging directory. There is a some before pushing the code into my repository, right? We need to add first. Once you add it, it will go to the staging directory. After that commit, it will ready to push that code. So let me add git add dot. So this is the third command I'm using. First command is git clone. Second command is git status. I'm just checking what are the files it has been modified. Now I'm saying git add dot. Dot in the sense present location. Whatever the present location, all the files will be added to the staging directory. If you see that only one file need to be added, yes, you can even type one file name. So this is how you can give the only file, one file. But right now I need to add all the files, right? So let me add dot. Dot is present directory. Okay, added. Now let us check again git status. Now you can see earlier it was in red color. Now it has changed to green color. That means it is ready now. So changes to be committed. Yes, you have added to staging directory. That is fine. Now you need to commit those changes. So to commit those changes, what is that? Git commit -m added text files. Added text file. So in the real time, you'll be if you use git commit, yes, it is going to commit, but you need to write why we are committing. So there will be a development history when we see the logs, right? You'll be able to, the commits why we have given the description need to be added here. Okay, by using -m command and in the codes, you'll be adding like this. Git commit. Oh, I have not. uh, Okay, I have not added. This is another computer. Okay. Okay. Now 3 files have been changed. Now it has been committed. Let us try to push now. Git push. If you see, now authentication has been completed. Now it is pushing all my code to my central repository. Right, git push is a command from local repository to I'm pushing the code to my central repository. So all 3 files should be seen here. So if you go to my code, so you can see all 3 files have been pushed to my central repository. So same way, if you are trying to add again some code, yes, new text test 4. I've changed some code. So again, if you get status, again you'll be able to see, yes, some changes has been done in my bootcamp folder. Okay, test 4. Okay, again I need to add dot enter git commit hyphen name added test 4 file. If you see, yes. So 4 files has been pushed to my repository. This is how will be using our git commands. So the main commands are so git add commit status. Okay, git init and branch rebase everything I'll be showing you. So git init is nothing but, for example, if you are trying to create a new repository. So let me new repo. I'll be creating one. Okay. New repo. This is not a git repository. Actually, this is not a git repository. Let me show more options. Git bash here. So right now I'm into this folder. So if you go to that folder and right click and use git bash, right, you'll be automatically into that path. I can say you're automatically into that path. So git init. So it is initialized empty repository. Yes, now it is master actually. Now it is a, let me see, you can see items. Yes, see, now it is a git folder now. That means it is a git repository file. So now you can add files here, same thing. test test one. Let me add one more repository here, which is already this is existing. Let me create one more. The test 1, 2, 3 I've created in my GitHub, right? Public, private, okay. Create repository. So I have created this. Let me go to my status. Yes. So two files has been added to my Git repository, right? So git add dot git commit -m added test file. No git status. You can see no branch, nothing to commit, working, everything is committed, but the destination I don't have, right? Git remote hyphen. I can see there is a no destination repository. So now I would need to have a destination remote report repository so that I can push this code to my Git repository, right? So let me try to copy this. Git remote. Whether it is going to show it. Let me see. Git remote -v. Git remote add. So now added Git. So now push. Let me see here whether my code is uploaded or not. Yes. So this is the two ways we can upload your code to my Git. So one is what I've done is one is already existing repository I have uploaded into my laptop and I've modified the code and uploaded the code into my repository. Whereas we have created some Git local repository into our local laptop. We have initiated the Git and you can see there is a once we have initiated we got this folder.git and from there we have mapped our local central repository and push the code to my central repository test 1 2 3 by using origin master. Right, it is already 10:15. Yeah, yes, Sunny, can you take over now? It is
Yeah, sure.
10:40.
If anybody has any questions, please raise your hand. I'll put you into the presenter mode and like you can ask any questions you want. If any of you doesn't have any questions, we can end the session as well. Yeah, you there? Can you hear me?
Yes, Sunny, thank you. Hi, Krishna.
Yeah,
What I wanted to ask is, you told about CI/CD tools, right? So, are those tools same for Azure as well as AWS, or is it different for both?
Now I'm just talked about only CI/CD pipelines and what are the tools we are going to integrate, right? It might be
Yeah.
Jenkins or it might be Azure DevOps. Yes, the tools will be the same. So you can use Terraform for both the provisioning in Azure as well as in Terra as well as in AWS as well.
Okay, okay. And also, does GitHub use I mean normal storage like physical storage, any of the physical storage, or
No,
just it's a cloud platform?
it's a cloud platform. Yeah, GitHub is a cloud platform.
Okay, okay. Thank you.
Anyway,
Yeah.
thanks, Uday. If anyone else would like to have ask any questions or anything, please raise your hands. I can pull you back into the presenter mode, and then we can go from there. Go ahead, Suresh.
Hey Krishna, are you able to? Am I audible?
Yes, yes, yeah.
Hey, first of all, I want to congratulate the team for the wonderful boot camp. Krishna, thank you for the insights. It is wonderful information for me. Thanks a lot for that. My question is regarding the Git remote, right? So can you let me know a little about Git remote command, please?
Yeah, Git remote in the earlier first time what I've done is I've cloned my already existing repository, right? Okay. So second time what I'm trying to do is in my local repository I've initiated the Git. I'm trying to copy my local files into destination repository where that is called as a remote. Okay. So earlier I was using a Git remote -v so that I in my local repository I don't know about the destination where I need to push that code to my central repository, remote repository. There I'll be using a Git remote and the destination repository name so that my Git will be identified that repository, destination repository. Then I'll be pushing that code to my destination repository. That was the
And
device.
also to
Yeah.
And also to add to that, Suresh, remote is nothing but like in cloud repositories. You could consider GitHub, like Bitbucket, all these kind of things are like considered as the remote repositories. So basically what you're trying to do is syncing the repository or the syncing the data which is sitting on your laptop or local machine into the cloud repositories, so that anybody can access it. And let's say an example, you are the engineer one and there is another engineer two. Okay, so you did all your code and everything and you pushed it into the GitHub or Bitbucket. Now the engineer two comes in and he pulls it from there so that he knows exactly what you have done, and then he can continue from there.
Thank you. Thank you both.
No, thank you. I saw someone else, Sai, I believe, raised his hand. Sai, you still have the question? Okay, I'm going to put you into the presenter mode. Thank you. So,
Hey Krishna. First of all,
Yeah.
it was a useful session. Thank you for that. So my question is, so you were explaining about the CI/CD, right? So you explained like few tools that we use for SCM and we
Yeah.
create pipelines where Jenkins and all will come into picture, right?
Yes.
So like wanted to understand like so how does Jenkins comes into picture here? So that is something you will go through tomorrow.
No, in our session, we are not going to cover Jenkins. Jenkins is just a workflow which will be integrating into the one of the pipelines, right? If you can use Jenkins or Azure DevOps. Right now, in our sessions, we are using Azure DevOps instead of Jenkins.
Okay, got it. So we'll get there closely in the
Yes.
next sessions. Okay.
Yeah. Yes.
and also Sai, if you wanna look at the content what we are presenting, you could go to tinyurl.com /BRAZ course. That will give you the entire content and what we are presenting as well.
Okay, sure. Can you tell that
I'll
you?
put that in the chat here so that it's helpful for you. Okay.
Yes, I'll take a look. Yeah, sure. Thank you.
There you go. Anyone else has any questions? Please let us know. Uday, do you still have the question? I still see your hand raised. Okay, cool. Anyone else before we end the session? If anyone else have any questions, or are we good to end the session? Okay, so we do have the day 2 happening tomorrow at the same time. If you have not registered, please register for the day 2. I see few of them register for only day 1, not for the day 2, day 3, day 4, day 5, day 6. We would be going into the weeds of the Azure DevOps starting from tomorrow. Thanks for all your time. And this bootcamp is just an overview of what we are trying to teach. Like our regular course is 45 days and it's 45 to 50 hours including the assignments. And I know few of people in here are already participating in our full-length course. If you would like to have like a full-length course, an in-depth course, please reach out to us. And if you need any details, please let us know. Thank you. 1 second. I'm just gonna. Yes, Sai, the sessions are already recorded, and you will be getting the slides as well as the recording in an email, as before the next session.
Okay, thanks, Annie. Sounds good.
No, thank you. Thanks, guys. Take care. Have a good one. Bye now.
Thank you all.